Simulations and predictions. Simulation. In order to obtain the probability of various events, a simulation is often conducted. It allows us to represent the likelihood of a real life event occurring by using an experiment with similar probabilities. This method is used by researchers when it is difficult to collect experimental data or when the theoretical probability is unknown. For example, tossing a coin, rolling a number cube, using a deck of cards. And this is stuff we've talked about in class. Or using a random number generator. It's just things you can use to simulate something else happening. And down here it says to brainstorm a simulation that could represent the same probability as the following situations. On a multiple choice question, there is a 25% chance of getting the answer correct. And we know that 25% is in force because 25 plus 25 plus 25 plus 25 is 100. So if we had a spinner that had 4 equal sections, then we know that that would be a 25% chance to choose one of those if they're labeled 1 through 4. Because it would be a 1 in 4 chance, which is 25%. The weather report shows that there's a 50% chance of rain. Well, we all know what we can use to represent 50%, and that's flipping a coin. Flipping a coin is going to be half and half. So flipping a coin is always 50%. You're going to get a heads or tails. The average an average basketball player makes 66.6% of his free throws. And that I know is, what can we do to get that in this on a number cube? Rolling a 1, 2, 3, or 4 on a number cube. There's equally likely chance that a baby is a boy or a girl. Let's use a deck of cards. So in a deck of cards, drawing a red card. We could do that to simulate because there's half red cards. There's 52 cards, so 26 red and 26 black. So that would also represent, a 50% chance. Use a simulation to determine the likelihood of each event occurring. Mr. and Mrs. Pinkerton have 4 boys. Every time people notice, they comment about the odds of this happening. The Pinkertons decided to set up a simulation with 10 trials to determine the probability. What simulation could be used to represent the likelihood of having a boy or a girl? That's 50% chance. So here's just tossing a coin. which outcome represents having a boy and which outcome represents having a girl. You could do that either way. Landing on tails represents a boy. And then landing on heads represents a girl. How should the simulation be designed in order to account for the 4 different children? The coin would have to be tossed 4 times and recorded, one for each child. And then you would do the 10 different trials from what it asks up here and record those. Record those outcomes. Making predictions. Probability can be used to make predictions for future occurrences by setting up and solving a proportion. The probability of rolling a 6 on a number cube is 1 out of 6. If the number of cube is rolled 50 times, then approximately how many times will a 6 be rolled? So you would set that up. The probability we have, okay, then how many rolls are we going to have the second time, which is 50. And you would cross multiply those, and you get 50 over 6. How many groups of 6 are in 50? Which is 8, which is 48, with 2 left over. And that simplifies to 8 and 1/3. Number 6, Kinsey surveyed a random group of 7th graders as to whether they preferred video games, sports, or neither. Used the survey results to make predictions for the entire 7th grade class with 350 students. Well, the first thing like this, remember we have to get a total. So 15 plus 22 plus 3 is 40. All right, what is a reasonable prediction for the total number of 7th graders that prefer video games? And when we do that, we've got video games is 15 out of the 40. And it's asking us for the 7th grade. And we know that it's 350 students. So we set that proportion up. And when we cross multiply these, you get 350 times 15, which is 5,250 equals 40x. Divide by 40. And x is going to equal, comes out to 131.25, but you can have 0.25 of a person. So 131. Based on the data, or based on the information in the table, what is the most reasonable prediction of the number of votes for video games in the next 80 votes? So video games is going to be 15 over 40, and it wants to know in the next 80 votes. So when we multiply that, 15 times 80 is 1,200. And 1,200 equals 40x. Divide by 40. X equals 30. So 30 students. Ellie had a package of 15 candies. After opening it, she found that there were 13 candies that were not green. If she opened 3 more packages, how many green candies could she expect in total? So out of that package of 15, it said 13 were not green. So that meant that 2 out of the 15 were green. So 2 out of that 15 were green. And if she opened 3 more packages, how many green candies could she expect in total? Well, if there's 15 candies in one package, how many is in the additional 3? So that's going to be 4 packages altogether, and that is 60. So how many green candies do we expect in 60 pieces? 2 times 60 is 120, equals 15x. Divide by 15, x equals 8. So we expect 8 green candies total. When you send the mail using the post office, you have an 80% chance that it is delivered to the correct location. If 430 letters are delivered on Monday, then what is a reasonable prediction for the number of letters that are delivered to the incorrect location? So if we set that up as a proportion, you got to think part and whole. So 430 letters are delivered. Remember, it's always at 100 here. And 80% of them are expected to be delivered correctly. So when we multiply these two, we get 34,400 equals 100x. Divide by 100. X equals 344. And then when you subtract it, 430 minus 344, you get 86. On Tuesday, it is reported that 500 letters were delivered to the correct location. Based on this information, how many letters was delivered on Tuesday? So it's asking how many, so we know that that's the whole that we're looking for. So 500 were delivered on Tuesday, and then 80% of those are going to the correct location. So 500 times 100 is 50,000 equals 80x. Divide by 80. You get 625 total letters were delivered on Tuesday.